So basic counting principle says this. One event can be chosen in P different ways, and another independent event can be chosen in Q different ways. Then the two events can be chosen successively in P times Q ways. And then you can expand that to more. And so let me explain that in context of one of these situations. So on number one here, a band sells t-shirts in 3 sizes. And so let's say we have size 1, size 2, size 3, right, that you can choose from. But each of those can be in 2 different colors, right? So you can choose size 1 and color 1, or size 1 and color 2. Or you could choose size 2 in color 1 and size 2 in color 2. Or you could go size 3 in color 1 and size 3 in color 2. And so this tree diagram here is illustrating the 6 different paths that you can take to create these the different t-shirts. Now instead of doing that, the basic counting principle says, well, let's look at a couple things here. Let's look, well, how many t-shirts are there? There's 3. And how many colors? 2. And so let's multiply them together. 3 times 2 and get 6. And that's a quick way to get to how many different possibilities there are, right? And that's what the fundamental counting principle is saying that we can do. So let's try that on number 2. Each player on a baseball team can order a bat with either natural or black finish with lengths 32, 33, or 34 inches. They can also either choose ash or maple for materials. So how many choices are there? So we want to count how many choices there are. Now we can draw another tree diagram. It's going to be a little bigger tree. Or we could try the basic counting principle, which says how many, we got 2 finishes. We got 3 different lengths. And we got 2 different types of materials. So 2 times 3 times 2 gives us 12 different choices. Okay. So read number 3 carefully and try to answer it correctly. So here we have two scenarios. The first scenario is you're choosing from 2 pair of skis, 2 pair of boots, and 2 pairs of gloves. And so that we have 8 choices here. But then there's another scenario where we go and buy another pair of gloves and add it into the pot. So instead of 2 different pair of gloves, we now have 3 different pair of gloves. So that would change. We still got 2 skis. We still got 2 boots. Now we have 3 pairs of gloves. And so now we got 12 choices. So the question says, how many more combinations are possible? Well, 12 is 4 more than 8. And so your answer is 4. Okay, so be careful there. All right, license plates. How many different 6-character license plates can be made if the first 3 characters are letters? How many letters are in the alphabet? 26 letters in the alphabet. And the next 3 characters are numbers. It should not say numbers, it should say digits. Digits are the things that make the numbers. Digits are 0 to 9. So like the number 12 is made up of 2 digits, a 1 and a 2. Okay? So you want to count 0 as one of your digits. So there are 10 digits. There are 26 letters. You're allowed to repeat these. So you can have a license plate that says AAA111. Okay. But it's possible, okay? So you're going to have more than 1 million for your answer here, okay? So we're going to start counting big numbers, and so it is okay if you bring a calculator and you have one to use one, okay? So we got 6 characters. So our first character is going to be a letter. So how many choices do we have? 26. And then I'm going to pick another letter, and I can repeat, so I still have 26 options to choose from. And then I'm going to pick another letter, so I got another 26 options to pick from. You're not going to want to make a tree diagram on this one, okay? And then we're going to switch to digits. How many digits are there? 10. 0 is, you got to count 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Adds up, you got 10 digits there. And you can repeat those as well. And so you multiply all that together, and if you have a calculator, which you probably want on this one, can somebody tell me what we get? 17,576,000 license plates. Okay. All right. I want to end with one more. So 5 is part of your homework, okay? I want you guys to end with 6. Let's try this. In how many different orders can 6 people sit in a row of 6 seats at the movie theater? Or this is the same problem as if I said, how many different ways in a group of 6 here, because I have this group in 6 chairs here, how many different ways can I seat 6 people in a group of 6? So try it out. Try number 6 out. So here are 6 seats, okay? So imagine you got your 6 friends, and you guys are deciding who's going to sit in that first seat. How many options are there for that first seat? All right, so you pick that person. That person sits down. Now you got to go to the next seat. Now how many options are there? 5 people. And then you have 2 people sitting down, and now you got to pick who sits in the next seat. We got 4 people to choose from. And then 3, and then 2, and then 1, and you get 720 ways. All right, this is what I mean by counting. Okay, we're counting. This is basic counting. 7, guys, you can skip unless you want a challenge. 7's a real challenge, okay? But you're allowed to skip it, okay?